Today, we're going to discuss the elimination of arbitrary constant. Now, the question is how to eliminate the arbitrary constant. So these are the following steps to perform the elimination of arbitrary constant. So number one, you have to determine the number of arbitrary constants or constants. The number two, differentiate the given equation n times according to the number of arbitrary constant. Shall we say, if there's only one constant in that equation, then you have to take only the derivatives until the first derivative only. Now, if you have two constant in one equation, then you have to differentiate until the second derivative. And if there are three constant, then you have to take up to the third derivative. Okay? And then after that, so for step number three, you have to eliminate the arbitrary constant or constants either by the method of elimination or substitution. Now, let us apply all these steps to solve the following equations. Number one, I have xy squared minus 3 is equal to cy. So by looking at that equation, there's only one constant, and that is the constant of c. So therefore, there's only one constant, then we take only until the first derivative. Now, the first term is a product rule, so apply the product rule. We have x times the derivative of y squared is 2y dy plus y squared times the derivative of x is 1 or 1 dx, then minus the integral of minus the derivative of 3 is 0, so no need to write 0, is equal to the derivative of cy. This will be now c dy. Now, since we want to eliminate the value of c, then I will define c from the original given. To solve for the value of c, so I can solve that one using the original given. So we know that we need to eliminate the value of y in order for us to solve for the value of c. So simply divide both sides by y. So therefore we have c is equal to xy squared minus 3 all over y. Now since we have now the value of c, then we are going to substitute that one to our derivative. So by substitution, we have to simplify at the same time. So the x times 2y dy, we have now 2xy dy plus y squared times 1 dx, we have now y squared dx is equal to c times dy, wherein c is equal to x y squared minus 3 all over y times dy. Now, looking at the equations, so we have the variable y in the denominator. So we want that to be eliminated. So therefore, we are going to multiply the entire equation by y. Now, using distributive property, so we have y times 2xy dy is equal to 2x y squared dy plus y times y squared dx, we have now y cubed dx is equal to y times this quantity. So we can cancel the y. So the remaining term now is the numerator. We have x y squared minus 3 of dy. Now, what I'm going to do next is that I will equate this equation to 0. Therefore, I will transpose the xy squared minus 3 to the left-hand side. So this becomes now 2x y squared dy plus y cubed dx minus the quantity of xy squared minus 3 dy is equal to 0. So what I did here, so I transposed this right hand side as a group. That's why I affix here, or I put the negative sign to this quantity of xy squared minus 3 dy. Then after that, I will be combining like terms such as dy 2xy squared dy and the quantity of xy squared minus 3 of dy. So if I'm going to combine that together, So having a common factor of dy, so I can write 2x y squared this minus x y squared minus 3 of dy plus y cubed of dx is equal to 0. Now, by looking at the quantity of 2xy squared minus xy squared minus 3, so the first two terms are like terms. Or so we can simplify that one, 2xy squared minus xy squared. So this will give us xy squared minus 3 of dy plus y cubed of dx is equal to 0. Or we can write now our answer as rearranging this one and starting with dx. So we can write now y cubed of dx plus we have the quantity of x y squared minus 3 of dy is equal to 0. So this will be now my final answer by rearranging it from in terms of dx plus dy is equal to 0. Or if you like, you can still write your answer in this form wherein dy comes first before dx. Okay, for number 2, we have y equals ax squared plus bx plus a constant. So by simply looking at the given, we could say that there are three constant or three arbitrary constant in this equation. So take note, there are three arbitrary constant. So if there are three arbitrary constant, then we have to take the first derivative, second derivative, until the third derivative. Now, let us start now taking the first derivative. So, okay, the derivative of y is dy is equal to the derivative of f of ax squared is equal to 2ax dx plus the derivative of bx we have b dx plus the derivative of c is 0. So therefore, no need to write on the third term. Now, as you can see on the right hand side, so they have a common term of dx. Now, if we are going to eliminate dx on the right hand side, therefore, we are going to divide both sides by dx. So by dividing this one of 1 over dx, or multiplying by 1 over dx, then we can have now dy over dx is equal to 2ax plus b. Okay, so we know that dy over dx is just equal to y prime. Okay, so we know that the notation of y prime is just equal to dy over dx. Now, we have now the first derivative. So after that, we are going to take the second derivative because there are three for our arbitrary constant. But we are not going to end up there because, as I've said, there are three arbitrary constant that you must take until the third derivative. Now let us take the second derivative. So we have now the derivative of y prime is equal to, we have the derivative of 2ax is equal to 2a dx plus the derivative of b, that since b there is a constant, then it is already 0, so no need to write plus 0. So again, if I'm going to divide by dx or multiply the entire equation by dx or 1 over dx, so we can write now as d of y prime over dx is equal to 2 a, because dx times 1 over dx, so the dx will be cancelled. The derivative of y prime over dx can be written as the d over dx of the y, okay, and that is just equal to y double prime. Again, why is that so? Because if we take the derivative of the first derivative, then it would be equal to the second derivative. And now our second derivative is just equal to 2a. Okay, now we have the second derivative, so we can now take the third derivative in order for us to eliminate the arbitrary constant of a. So I will write here, so taking the derivative of y double prime is equal to, we have the derivative of 2a, so they are now all constant, then the derivative of that will be equal to 0. We know that the derivative of the second derivative is equal to the third derivative. So we could say now that the third derivative is equal to 0. Okay. Now, since we have eliminated already all the arbitrary constant, then the equation now will give us now the final answer of y to the third derivative is equal to 0. Okay, for number 3, we have a y is equal to c sub 1 of e raised to x plus c sub 2 of e raised to negative x. So in this equation, we have two arbitrary constants that are named as c sub 1 and c sub 2. So take note that there are two arbitrary constants, then we are going to take until the second derivative. Now let us, we have the derivative of y, we have dy is equal to the derivative of c sub 1 of e raised to x is equal to c sub 1 e raised to x, and then derivative of x is 1 dx, so just write here dx, plus we have the derivative of c sub 2 e raised to negative x, and then take the derivative of the exponent, which is negative x. So the derivative of that will become negative dx. And then we have, since we have all dx here, then we are going to divide. But before that, let me multiply this, the second term, multiply first the second term in order for that to be simplified. So we have dy is equal to c sub 1 of e raised to x dx, then positive times negative, we have negative c sub 2 of e raised to negative x dx. Now, since we have a common of dx, then for us that to eliminate, and then we are going to multiply the entire equation by 1 over dx, or simply divide all the terms by dx. So we need to divide by dx so that when the left hand side becomes dy over dx, and we know that dy over dx is equal to the first derivative. Now let's multiply. So we have dy over dx is equal to c sub 1 of e raised to x minus c sub 2 of e raised to negative x. So this is our first derivative, or I can just write this one is equal to y prime. Okay, or you can just let that one as dy over dx. Now, solving for the second derivative, so we have now d over dx. I will use another notation. So d over dx of dy over dx will be equal to the derivative of this. We have c sub 1 of e raised to still c sub 1 of e raised to x minus the derivative of this is c sub 2 of e raised to negative x. We have c sub 2 of e raised to negative x times the derivative of the exponent. We have the negative dx. Now, simplifying on the right hand side, we have c sub 1 of e raised to x, and negative times negative dx becomes now c positive of c sub 2 of e raised to negative x. So on the left hand side, if you're going to multiply that one or take the derivative, so that is now the result is d squared y over dx squared, and we know that this notation is just equal to y double prime. Then we know that y, we have to consider this one. Looking at this, all right, we have c sub 1 of e raised to x plus c sub 2 of e raised to negative x is equal to y. Okay, so we could write now here that y double prime, instead of writing d squared y over dx squared, I will use the notation of y double prime. And on the right hand side, that is actually this one is equivalent to that. So we could write that c sub 1 of e raised to x plus c sub 2 of e raised to negative x is just equal to y. Then equating that one to 0, so therefore the final answer now we have y double prime transpose minus y is equal to 0. And this is now the final answer. Okay, for number 4, we have x sine y plus x squared y is equal to c. We have to take the derivative of the first term of x sine y is equal to x. Then derivative of sine y is cosine y dy plus sine y times derivative of x is dx, or 1 dx, or just dx. Now on the second term, plus x squared times derivative of y is dy plus y times the derivative of x squared is 2x dx is equal to 0, because the derivative of a constant is 0. Now, simplifying this one first, I will just rewrite. So we have x cosine y dy plus sine y of dx plus x squared dy plus, so this is what I'm trying to multiply. So we have now y times 2x dx is equal to 2xy dx is equal to 0. Now, if I'm going to group together that having x, so we have dx rather, so this one is dx, and we also have another dx, and the one that I did not highlight, then that is all in terms of, you can group together as well in terms of dy. So I will write first in terms of x, so that we have a uniform way of writing the final answer, that we are going to present in terms of dx first, followed by dy. So in that case, class, I have now 2xy. I start with algebraic operation or algebraic coefficients of dx, followed by the trigonometric coefficient of dx. So we have 2xy plus sine y of dx plus, in terms of dy, so we have now x squared plus x of cosine y. This is in with a common factor of dy is equal to 0. So that would be now our final answer for that problem. For number 5, we have derivative of y is dy is equal to the derivative of c sub 1 of e raised to x can be written as c sub 1 of e raised to 2x, and the derivative of 2x is equal to 2 dx plus the second term, now we have c sub 2 of e raised to 3x, and the derivative of 3x is equal to 3 dx. Simplifying the right hand side, we have now dy is equal to 2c sub 1 of e raised to 2x dx plus 3 times c sub 2, we have 3 c sub 2 of e raised to 3x dx. Now, similar to what we have done in the previous example, since there are common of dx in the right hand side, then we are going to divide both sides by dx, or simply multiply by 1 over dx. Okay, so multiplying that one, we can now have dy over dx, which is actually equivalent to the first derivative, is equal to 2c sub 1 of e raised to 2x plus 3c sub 2 of e raised to 3x. So that is now our first derivative. And next, we have to take the second derivative. So we have, I will just highlight this one. This is our first derivative. All right. And so we have to solve now for the second derivative. We have d over dx of dy over dx is equal to, taking the derivative of this, we have 2c sub 1 of e raised to 2x times 2 dx plus 3c sub 2 of e raised to 3x. Derivative of 3x is 3 dx. So simplifying, we have now the left hand side becomes d squared y over dx squared is equal to 2 times 2c1, if we have 4 c sub 1 of e raised to 2x plus, on the second term we have 3 times 3 is 9, so we have 9 of c sub 2 of e raised to 3x. So we have now the first derivative and a second derivative. But as of this moment, we were not able to eliminate yet the c sub 1 and c sub 2. Now, we are going to let c sub 1 of e raised to 2x by a single variable, as well as on the c sub 2 of e raised to x, in order for us to solve easily. Okay, it could be written now in a simplified form. So I'm going to let now, so I'm going to let a is equal to c sub 1 of e raised to 2x, and I will let b is equal to c sub 2 of e raised to 3x. Okay, so from the original equation, we can now rewrite in terms of A and B. So we have here, I will write it again. From equation number 1, I will say that this is our equation number 1. So from there, I can rewrite that one as y is equal to c sub 1 of e raised to 2x plus c sub 2 of e raised to 3x. Then I will use now the assumption of A and B, where A is equal to c sub 1 of e raised to 2x and B is equal to c sub 2 of e raised to 3x. Now, if I'm going to change that one now, so this will be equal to, we have y is equal to, we have c sub 1 of e raised to 2x is equivalent to A plus, while the c sub 2 of e raised to 3x is equivalent to B. So in simplified form, this is now our first equation. Now, on the second equation, I will use the first derivative. We have So we have the first derivative is y. This is equal to first derivative. So we have now y prime is equal to 2c sub 1 of e raised to 2x plus 3 of c sub 2 of e raised to 3x. So changing this term in terms of a and b, so we can write now y prime is equal to 2a plus 3c sub 2 of e raised to 3x. It can be written now as 3b. So this is now our equation number 2. Now, since we still have the third derivative, so I will use the third one. Now we have, this is from the second derivative, d squared y over dx squared is just equivalent to y double prime. So we have now y double prime is equal to 4c sub 1 of e raised to 2x plus 9 of c sub 2 of e raised to 3x, wherein if I'm going to change the term of c sub 1 of e raised to 2x in terms of the assumption of a and b, therefore we could write y double prime is equal to 4a plus 9b. So that we have now the three equations. So we have the first one is this one, and the second one we have this one. Okay, in terms of a and b, and the third one we have, okay, we have y double prime is equal to 4a plus 9b. So from their class, we are going to use now a substitution method. So from y is equal to a plus b, we can define that one now. So I can use the other slide. From equation number 1 class, so we have y is equal to a plus b. Now, if I'm going to define a, so therefore, we have a is equal to y minus b. Now, if I'm going to substitute in equation number 2, so from equation number 2, we have y prime is equal to, I will write first the meaning of my y prime. We have 2a plus 3b so that we can be properly guided. Again, that is now y prime equals 2a plus 3b. We are right 2a plus 3b. Now, after that, I will be using the meaning of a that is coming from our equation number 1. So, replace a by y minus b. So, we have y prime is equal to 2 times the meaning of a is y minus b plus 3b. So by simplifying, we have y prime is equal to 2y times 2 times b, we have 2b plus 3b on the last term. So simplify it further, so we can write now 2y negative 2b plus 3b is equal to b or just 1b or just b. So we have now y prime is defined as 2y plus b. Now we're gonna solve for we have now one variable, one arbitrary constant, which is b. So we are going to solve for b. Therefore, b there is equal to transpose the 2y, so that can be now y prime minus 2y. Okay, so we define now a and b. So we have only two unknowns, so we can use that one now in the third. Okay, since we have now b, so we can solve a. We can now substitute b there in our first equation. So from here, we have now a is equal to y minus b. So we have a is equal to y minus the value of b, which is now y prime minus 2y. So therefore, simplifying this one, we have y minus y prime, negative times negative 2y, we have positive 2y, and then combining like terms, we can define a as y plus 2y. We have now 3y minus y prime. Okay, so we have defined now the value of a and b. So since we know already the value of a, the meaning of a and b, so we can now use the third equation from the second derivative. From the second derivative, which is now y double prime equals 4a plus 9b. So we have y double prime is equal to 4a plus 9b. So we'll check. We have 4a plus 9b. So we are using that one now, wherein we can substitute the meaning of our a and b. Okay, so we know already the value of a, which is this one. This is the value of our a, and this is the value of our b. So therefore, we can now solve the equation. So we have y double prime is equal to 4 times the value of a, which is now 3y minus y prime, plus 9 times the value of b, which is y prime minus 2y. So simplifying that one, we have this using distributive property. We have now 12y minus 4y prime plus 9 times the quantity of y prime minus 2y. It gives us the product of 9y prime minus 18y, and then combining like terms, so we have 12y minus 18y, that is equal to negative 6y. And then in terms of y prime, we have negative 4y prime plus 9y prime is equal to 5y prime. Now, I'm going to equate this equation into 0. So therefore, y double prime and arranged at the same time. So y double prime minus 5y prime plus 6y is equal to 0. And this is now our final answer.